Okay, hey everyone. Morning. We are live today with DocumentDB from the dining table. I'm your host Chad Tyndall, and my co-host Joseph. It's just Joseph.
Nailed it, Chad. You got it.
Yeah,
Just
thanks.
Joseph. Just your average Joe.
Anything but average, Joe. Uh, yeah, I'm a NoSQL specialist solution architect here at AWS. Joe, if you want to introduce yourself.
Hi, I lead product for Amazon Document DB.
Yes, and as always, our show is sponsored by the TV show Cobra Kai. I hope you have your official Cobra Kai mask ready to go for the show.
No mercy. Cobra Kai
Database
strikes first.
deserves no mercy. Yes. Our show is also sponsored today by LaCroix, the makers of the finest sparkling water. All right. This limoncello flavor is great. It goes good with bourbon, gin. You can actually throw real limoncello in for your day drinking needs, whatever you need. It's good to go.
Big
Really
nod
is,
out to our sponsors.
Yeah, big nod to our sponsors, as always. All right. Let's jump right in. One of the things that we do every episode is just give a very brief introduction to DocumentDB for anybody who is joining us for the first time. It's not something we spend a lot of time on, but if this is your first time here and you haven't worked with DocumentDB before, we do want to give you just a brief introduction. So DocumentDB is a fully managed MongoDB compatible database service here at AWS, and it is fast. It can serve millions of requests per second. It can scale in minutes to have up to 15 read replicas. It's a fully managed database, so you don't have to worry about hardware provisioning, backups, patching the servers, anything like that. It's all managed by the AWS service itself. It's compatible right now with MongoDB 3.6, so you don't have to use any new drivers in your application. If your application is using MongoDB 3.6 drivers right now, you should be good to go in terms of working with DocumentDB. All right, Joe, anything you want to add to that?
Nailed it, Chad.
Nailed it.
Absolutely nailed it.
All right. Well, look, like I said, we don't want to spend too much time on it, but if you want more information, background on DocumentDB before we dive in, um, there's a blog post that talks about, it's basically a roundup of all of the sessions from last year's reInvent. And so there are deep dives into DocumentDB. There's customers talking about how they use DocumentDB. You can see our executives talking about database and analytics services in AWS. There's some hands-on workshops if you want to go through it there. So we'll post all this stuff in the YouTube channel, and there'll be a link to these slides as well if you want these links, or you can just Google DocumentDB 2019 reInvent recap, something like that. It should come right up.
And we're getting ready for all the new reInvent sessions right now. So a lot of the stuff is in process. So once we have the catalog and the sessions we can share, we'll share those on an upcoming episode. Got some fun stuff from the product side, and also some great customer presentations coming this year as well.
All right, very good. All right, let's dive right in. So we want to start a new bit where we talk about any recent product releases that have come up in the last couple of weeks since our last session, since our last episode. So I'll let Joe talk about these.
Yeah, we have some goodies. So first, so Glue launched support for DocumentDB and MongoDB in maybe it's August or July earlier this year. And recently, in the last couple of weeks, they also added support for now being able to go crawl in first schema with Glue Crawler and being able to use that for your Glue jobs. So it's a nice additional feature to help inferring schema and being able to use that schema to be able to do batch loads from wherever your source is to your destination. So that's a nice one. We also added support for $out for folks that don't know what $out is. It's basically like select into table for a relational database, so you can output the results of, say, an aggregation pipeline query into a new collection. So that has been a big ask of customers, and that's one we are pretty excited to get out. And we also went.
This is pretty common, I think, Joe, where people are calculating various aggregations and they want to save them so they can query them very quickly later, right? That way they don't have to recalculate the aggregation every time someone views a page or something like that. They can just calculate it once and save it into a collection so they can load it very quickly.
Yeah, it's a really powerful operator, being able, all types of, intermediate result stages, some sorts of caching, it was a big ask. So we were really excited to get that one out. And, as always, we continue to work backwards. Some of the capabilities our customers want us to build, we'll keep adding. We also went back and improved and did quite a bit of work to increase the number of connection and cursor limits on each of the instance sizes. On some instance sizes by as much as 10x. So, that's give our customers a lot more headroom on instances, be able to scale a lot better, and just a general overall improvement to the service. So we're excited about getting that one up as well. Especially, we see this a lot for applications and kind of, pretty pertinent to what we're going to be talking about today, that spin up just, a whole bunch of connections from, say Lambda or ECS or EKS. And they just have just a lot of connections in their applications, just given the distributed nature of how they're building their application. So this will give customers a lot more headroom to add those additional connections. So really excited about that one. It's been a long ask. We're really, really happy to get that one out.
Can you say what we changed to make that possible? Was it just that we were being really conservative before, or is it that we made something more efficient on the back end to allow that increase?
It was both. I think we were being, I think one of the things that we were conscious of when we launched was, just overall memory consumption on the instances. What we didn't want to have happen is you open up a bunch of instances and cursors, and then there's no memory left to do anything else on the instance. So we definitely went back and reevaluated that. There were some things that we did do to improve memory utilization. Both from just kind of the optimization of the connection code paths, but also on the ability to go back and reclaim or clean up unused connections. So it gives us, it gives us the ability to do some kind of, reclamation or garbage collection behind the scenes to, if somebody spins up 10,000 connections and then they, don't close them, then we have a mechanism to go clean a lot of that up now. So did quite a bit of work there actually behind the scenes.
Cool. All right. Yeah, that's good. And so hopefully we'll have stuff to talk about, every episode or maybe every other episode.
Yeah, I think
the releases.
Pretty sure for the next 2 episodes, I think we're going to have some fun stuff to talk about. So I'm very excited about that.
Awesome. All right. Thanks for that, Joe. And there were a couple of unanswered questions from episode 1 that I wanted to pull up here. We just missed them in the chat. I think we didn't talk about them. And I don't want people to think we're ducking the hard questions here. We're here to talk about the meat of the product, and we're going to give you the real deal. All right, live from the horse's mouth, or probably mixing metaphors there. I do that a lot. But we did have a question. Arjun SK15 asked, "Is DocumentDB compatible with the Spring Mongo data driver?" And I think the answer is yes, because it's built on the Java driver underneath, right, Joe?
Yeah, that's correct. So DocumentDB is compatible with both the regular Java driver and the async driver, which builds on Spring. We definitely know, we have customers using this framework with DocumentDB, and I'm not aware of any issues that anybody else has had. So I would say, the answer to the question is yes, but is always with anything ever in software, you're always going to want to test. And if there are any issues, letting us know. We would love to hear about it either on, Stack Overflow, the AWS forums, on the show. You can reach out to Chat or I on Twitter, either one of those. We'd love to hear the feedback, but otherwise, I will say yes today.
Good. And we have another question. Do you think the DocumentDB would eventually diverge from the Mongo API to become a totally different API? That's a really interesting question.
It's a really great question. I think, what we've always done at DocumentDB and what we'll continue to do is always kind of work backwards from what our customers want us to build, and just kind of like, dollar out. And a lot of the stuff that we're building now is actually more compatibility, not less. I think, what you've seen where we've really spent our time to innovate is not on the API, but on the database architecture, where we built, DocumentDB on a cloud native distributed storage architecture that allows us to do a lot of things that, lets us help our customers scale much faster than they could, no impact backups, all those types of stuff. On the API compatibility, we've actually, we spent a lot of work actually becoming more compatible. So, I think it's not diverging, it's converging. But, we'll continue to listen to our customers. If there's additional stuff they want us to add that's outside the scope of the 3.6 API or other API, we're definitely open to doing that. We're, it's more or less about solving problems, not doing things just because. So, but great question. I mean, I think it's a very, very pertinent question, and we'll continue to listen and learn here. But yeah, most of the stuff is going to be adding new stuff to 3.6.
Cool. Yeah, I imagine we'll be having a bunch of announcements about this type of stuff at reInvent as well. Whatever's coming out, I don't know, but we'll see.
Maybe.
It's exciting. Maybe.
Can't confirm nor deny, Chad.
All right, fair enough. You could tell me, but you have to kill me.
That's right. That's a long car ride, man. I don't know, from Seattle to New York. That's right. You're in the NYC.
Absolutely, it's a great car ride, though. It's fun. Driving cross country. Everybody should do it at least once. Everybody should do it at least once.
Oh, there's
so much emptiness in between.
I grew up in the emptiness, man. You can fly over. I grew up in Minnesota and Iowa, so smack in the middle of the emptiness, which I love. So it's good stuff there.
I grew up in California, but it was the empty part of California. I mean, I was literally we used to milk cows on the farm and milk goats, and my grandma wanted to make a cake. She'd send me out to steal an egg from the goose in the yard, and that's not easy to do when you're 6 years old. Those things are mean. They'll bite you, and it hurts.
Oh, maybe next time we can have pictures of those days back in the farm.
I know that there's a picture of me feeding baby goats from a Pepsi bottle with a rubber nipple on it, for sure. I have that. I think my wife has it somewhere in the archives. So she hunted it up and put it in our wedding, photo thing, whatever it was. All right, good. Moving on. Send us your questions in the chat as well. Like, we'll answer them here. If we miss them for some reason, we'll follow up in the next episode. Like I said, we're not here to duck the hard questions. All right. Brent Contained has joined us from where? From Texas, in the emptiness of Texas? All right. I think that's where he is this week. I wanted to just talk Frisco, yeah, north of Dallas. That's where all the Cowboys live, right? Brent, don't you live out near Cowboys headquarters or something like that? Yeah, I think he does. All right, I wanted to talk very quickly about how queries work because I think that it's easy with NoSQL databases they're so easy to use. All right, they don't require much setup. They don't require a lot of complicated configuration on the application side. You really can just spin them up and start using them, and that's great. It's very powerful. It's very developer friendly. All of that stuff is true. It is kind of a double-edged sword because it's easy when you're just starting out to just kind of do whatever, just explore what the database is capable of and make stuff work and make progress with your application. And it's easy to make a mistake in a way that can come back to haunt you later, because when you're working at a small scale, like you're just on your laptop, you're inserting some sample data or whatever, mistakes won't hurt you that much. If you make some sort of problem which leads to a scalability problem later, when you're operating at small scale, it's not a problem yet. And it's something that you'll notice later down the road and need to fix. And so it's good to have a mental model, I think, of how databases are actually working with your data behind the scenes so that you can try to avoid some of these. And we will dive into a number of learnings that we've had from customers behind the scenes right after this. But I think if people get a mental model of how queries work, it will make the rest of the conversation today make a lot more sense. So when you create a collection and start inserting data into it, you can query it right away. But if you start querying on fields which there's no index for, then DocumentDB is going to scan every document in the collection for every query. And like I said, that's fine. If you have hundreds or thousands or even tens of thousands of rows, that's fine. It's going to be really fast still. But if you start operating on data that has millions or even billions or trillions of records, then, which certainly is possible in NoSQL databases, you're going to be in a world of hurt if you start doing table scans for every collection, because it is order in. All right, so you definitely don't want to be doing table scans for every query. Really, it'd be nice if you didn't have to do any table scans for any query. And the way you avoid that is by adding indexes. So if you create an index in DocumentDB, you'll create an index on specific fields or combinations of fields. And so when you run that query, if there's an index available for it, the database will apply the conditions on the index keys to reduce the number of documents that it needs to analyze. So essentially, if you had like 1 million records and the fields that were in your index could narrow it down to like 10,000 records, that's great. We just cut out 990,000 records we don't need to look at. And now we're going to do the scan within those 10,000 records, or anything that wasn't part of the index. So this is in two phases. First, we're going to look for things in the index to sort of narrow the range of what we have to examine, and then we'll scan whatever's left, right? So we call that the filter stage. So there's always the index stage and then the filter stage. Okay, so what you want to make sure you do is you want to make sure your indexes are highly selective, really as selective as possible, because you want that first stage to weed out as many documents as possible so that you have as few documents left to scan and filter through. All right, you also want to make sure that your cluster instances are large enough to keep all of your indexes in RAM, as well as what we call the working set, which is the documents that you're touching regularly. If you have a large data set with hundreds of terabytes of data, probably not possible to put all of your documents in RAM. But the part of your documents that you're working with regular, and those might be the ones that are just more recent or whatever, you want to make sure you can keep a lot of those in RAM as well, so that you have mostly cache hits instead of cache misses. And then you can use the explain and hint operators just to make sure you're using the right index. And that's really what our next guest is going to dive into. Joe, anything you want to add before we dive in?
No, I mean, I think one of the, we use this terminology a lot, is selectivity in indexes, or you also hear us kind of use the terminology cardinality. And the reason being, and I know, Meet's going to talk about this, but the higher the selectivity, the better the performance. And it just, what we don't want people to do is typically don't want people to do is create indexes on, fields like true, false. Like the database doesn't, this is true for really any database that has indexing, is those scenarios usually aren't super beneficial to increasing performance. You want things that are like, very unique values where, you're going to have very few or very little duplicates. And that really helps you utilize the database. So that's, when you think about index design, think about uniqueness.
Good. Yeah, that's the cardinality of the index. Because if you had an index which was on a Boolean field, like you said, then your index still is only going to filter out maybe half your documents, and you'll still be scanning half the table instead of the whole table, which is better, but it's still order in, really. You haven't made any dents in the running time. So, all right. So yeah, we're going to dive into some learnings from behind the scenes that deal with these types of questions. And let me stop sharing here. Actually, we're going to bring in a guest here. We're going to bring in Meet Bhagdev, who is also another product manager from DocumentDB. And let me bring him in. Hi, Meet. Can you hear us?
Hey, I sure can. Can you guys hear me?
Absolutely. You're here. You're good to go. Let me stop sharing my
right.
screen, and you can share your screen.
Sounds good.
We now have 100% of the product team for DocumentDB represented.
That's awesome.
All right. Do you guys see my screen?
Yep, it's up. It's not in presentation mode, but
should be now. Is it?
Yeah, now it is. Now
okay.
It is. Very good.
Perfect.
You have the
Thanks. So yeah, just wanted to kind of continue the discussion. Like Chad mentioned, some of the basics. What I wanted to talk to you guys today about just some of the learnings that we've seen as we run the service. We have one of the benefits of working with multiple customers, and with that we have we see several patterns, we have several learnings, and I have a few examples that I wanted to share with you guys today from behind the scenes. So let's dive right into it. So the first one, and pretty simple, like Chad mentioned, is creating indexes really improve query performance. And for this, let's base this in an example that we saw from one of our customers. So we had a customer reach out to us, asking us, and they basically wanted to learn why were their queries performing poorly. And obviously these are example queries, not reflective of any actual customer data. But here's an example query. So the customer had a collection called movies, and they were essentially trying to find all movies where the value of the field year is greater than 2010, and the title has the string Avengers in it. So essentially, we kind of asked them some questions. We're like, okay, we're happy to help you. can you share some more details about this query? Specifically, what's useful to look into when you're trying to examine a slow running query is the explain plan. You can also use the DocumentDB profiler to profile these query plans. But this is essentially the execution plan for your query. So this query plan will tell you, where bulk of the time is spent by the optimizer. Is it on a specific field? Is it because it's doing a collection scan or something else? In addition to that, we also ask the customer to run get indexes. So get indexes will essentially give you the list of indexes on your DocumentDB cluster, DocumentDB collection. We wanted to make sure that the right indexes were getting created and used. So when you look at the explain plan and make sure the right indexes are created, that gives you a good idea as to what's if there's anything wrong with the query, what's happening, and how to make it better. So, looking through the explain plan, the customers kind of shared that with us. One of the things we noticed is this thing called the call scan. So what does this call scan mean? This essentially means that when the customer ran the query, the optimizer ended up scanning the entire collection to answer the query. This again is fine if you have a few hundred documents, few thousand documents, but as you get into a larger scale, if you're performing collection scans, it's quite expensive. You're essentially scanning the entire data set. You're loading a lot of data into memory to answer your query, which is often not efficient when you look at the performance stats. So it was pretty clear in this case that we needed to create an index. We also checked that is it just the optimizer is not picking the right index, and that was not the case. In this case, we ran get indexes, and as you can see, there was only one index on the ID field, which is automatically created. And since the query was not on the ID field, this index wasn't really very helpful. So the summary on this one was, to eliminate the collection scan, we recommended the customer to create a compound index on the two fields that were part of their example queries. So as if you remember, the customer was querying on year and title. So in this case, we created a compound index that included both these fields because they appear together in the query. So with the index, the query's performance basically improved from 200 milliseconds to 90 milliseconds. And obviously the speedups you'll see here will be even more drastic once the data size increases. So what I want to do here.
Can you talk about? Can you talk about what really is a compound index? Why they needed to use one of those?
Sure. So there's different types of indexes in DocumentDB. There's a single field index. There's a compound index. There's a multi-key index. So a single field index is essentially an index that you would create on a single field, like the name suggests. So let's say if we were to create an index in isolation on the field year and not on title, then that would be a single field index. A compound index is one where you create that index on multiple fields. And the reason to use a compound index versus a single index in certain scenarios is if those two fields appear together in bulk of your queries, then it's more efficient for the optimizer to use both those fields together in a compound index. What this essentially does is it helps reduce the amount of data you scan. And in this case, given both these fields often appear together in the query, it made more sense to create a compound index than a single field index.
And in this case, the compound index could also work for single field queries too, right?
Oh yeah, absolutely. So this index would also be useful if you're just doing a query, let's say on year or just on title. So actually, I wanted to just show you guys a demo. So how the before and after looks. So I'm gonna jump right into. Oops, sorry about that. So Chad, is my screen coming in fine? I think so. Okay. So what I have here, I'm in a Cloud9 environment, and what I'm gonna do is just run some queries against my DocumentDB cluster against the sample data set that I have. So if you remember from the slide, the query we have is essentially doing a find on two fields where the year is greater than 2010, and the title has the string string Avengers on it. So today, if I right now I don't have any indexes. If I run this query, you'll see we get 2 responses. We had 2 Avengers movies, one in 2012 and one in 2015. What I want to see in addition to that is the explain plan. So to do that, I'll essentially add explain to my query, and you'll see that this query is performing a collection scan to answer the query criteria, and it's taking roughly 24 milliseconds. So what we can do here to speed things up a little bit is create a compound index like we talked about. So to create a compound index, you can just run a create index command. So let's go ahead and do that. So now if I do get indexes, you'll see that I have 2 indexes, one which is the default one on the ID field, and then another compound index on year and title. Now if I run the same query again, you'll see that I'm actually doing an index scan. So the previous stage, which showed a call scan, when you look at the execution stats, in this case is now showing an index scan. And if you look at the execution time, it essentially went, if I can just scroll up, from 24 milliseconds to 3 milliseconds. So it's quite a significant speed up. And like I mentioned, as your data set grows, you really start to see the difference between having indexes and not having indexes.
And how many rows do you have in there now?
I actually don't have a lot. I think it's a few thousand, and I think we're already seeing the difference with a few, because it's just a demo data set. But yeah, you already see.
Exactly. It's not even a big data set.
Exactly.
You got like
so,
a 1/10 the speed.
Yep.
1/10.
All right. So I'll dive right back into the PowerPoint here. So that was the first.
We had a question. We had a comment or a question on compound indexes. So if you create a compound index and you want to query on the fields within that compound index, say this case we have year, comma, title. Can you query on both of those fields, or is and I think the question is more kind of leading about like you can still use year and you still get the selectivity of the index on year, but not title. Is that correct?
Yeah. So let's give that a shot. So I think if I understand this correctly, the query that they're looking to run is something like this. Is that correct?
That's right. Does that still use the index? And then if you kind of said, I want to do the same thing on title, then does that actually use the is that actually conducive to using a compound index if you're querying on the trailing value or the other value within the index?
Yeah, so it's one of those things, it really depends, whether you want to create multiple indexes. Depends on what most of your queries look like. If you do have queries where you're doing just single queries on, let's say, title or year, then it does make sense to have, additional indexes, which would be single field indexes. But, it depends on what most of your queries look like. But let's give that a shot and, see what happens here. I think I'm missing something here. Let's try with this one.
Nothing like a live demo.
Yeah. All right, so let's see. What am I missing in this query? I'm missing an extra bracket. There you go. Okay, so as you can see, so even if we were doing just a find on the year field, and even though our index was actually a compound index, we were still able to use the index, which is year title compound index, to answer a query where you were only filtering on one of the fields in the index. So similarly, for the other one, I think.
Yeah,
If you
you'll need the closing bracket there too.
That's right.
Those brackets matter.
So in this case, the optimizer did not pick the index, which could happen.
It only works for the leading keys.
Exactly.
Yeah, it only works for the leading keys, right? Yeah.
Yep. So in this case, if you do have certain queries where you are doing filters on single fields, it does make sense to create additional indexes on those specific fields.
And then we call that index intersection. Yeah, I think that's it's a valid point too. Is the query processor can actually pick up multiple indexes in this case as well. If we did have two single field indexes on each of the attributes or each of the fields.
If we had an index on year and an index on title, then DocumentDB could do the index intersection for us. We're having a discussion with one of the engineers though. I think I don't want to call it a downside, but the behavior of that is such that if you did a hint operator, then it would preclude the use of any index intersection. So that's a trade-off there. Yeah.
That's right. Good discussion. Right. All right.
So talking about hint, that actually, dives right into this next learning that we've had. So the next learning was, customers can use hint when the DocumentDB optimizer is not selecting the right index. So let's talk a little bit about, why you would need to do this, or when this could even be applicable, by taking another customer example. So we had a customer who reached out to us, and they basically wanted to learn, hey, why is my query not selecting the right index? I followed your docs. I've done all the best practices. I've created a single field index. I've created a compound index. And in their case, the query was essentially doing, again, a find across two fields. One find on item ID, which is looking for, let's say, the value 101 here, and then the value field where they're looking for documents that match the criteria where value is greater than 5 and less than 10. So in this case, the customer had two indexes, a compound index on item ID and value, and a single field index on item ID. The problem that they saw was that the DocumentDB query optimizer was selecting the single field index, but not the compound index. Their query was still running faster than without an index, but they were expecting the optimizer to pick the compound index instead of the single field index. This is because the query filters on both the item ID and value, and they essentially, since they wanted to use a compound index that helps filter both those fields to save on collection scans. In this case, because the optimizer was picking a single field index, it was resulting in a collection scan for the filter specifically on the value field. And just to kind of talk about why this could happen. So the DocumentDB optimizer actually uses a statistics-based calculation to estimate the best plan. And once we do calculate these best plan, we cache them for specific query shapes on your DocumentDB instances. So sometimes these statistical estimations could yield unexpected results, and oftentimes they just resolve over time. As you run the query more often, the optimizer starts picking up the right query plan. But in the event, if it's not choosing the right query plan, you can suggest the optimizer to use a specific index. So in this case, what the customer could do is use the $hint operator to force the query optimizer to use a specific index to fulfill the query. So we know that the customer had two indexes here, and they specifically wanted to use the compound index. So what they could do is essentially at the end of the query, just add hint, and in that hint, you specify the index name. So what this hint would do is it essentially would tell the optimizer that, hey, I would like to serve this query using this specific index. And once the optimizer has that hint, it will then switch the index over from the one that was using previously to the one that you would like the query to use. It's not often that you need to use hint, but there are certain cases where hint is pretty useful, especially where you have two indexes that are both good candidates for the query, where one may be just slightly better than the other, and estimates are sometimes not accurate. It's again, like I said, a rare thing, but it is one of the tools that customers get to have in their arsenal in the event that they need to do a force, not a force, but essentially suggest the optimizer to use a specific index. So in this case, once the customer added the hint, the query optimizer started picking the right index, and then essentially their query avoided that extra collection scan on the second field, which is the value field.
Yeah, we did have we had a comment in the chat. Why is Bob not allowed? It's ask, is hinting not cheating? And I want to address this because a lot in NoSQL designs, not just with DocumentDB, but we do a lot of designs with people using DynamoDB and other NoSQL databases here too. And for example, in DynamoDB, there is no query optimizer that picks an index. You know, it's actually, you have to explicitly say for every query which index you want to use. And so you can't accidentally end up in a situation where you're doing a table scan and you didn't realize it, or it's using the wrong, suboptimal index. You know, you're creating these indexes so that because you have specific query shapes that you want to run. And, I don't think there's anything wrong with saying, look, I created this index specifically for this query, and I want you to use it for this query. And I think that's fairly normal when we talk with customers to tell them to do that. So I wouldn't consider it cheating.
Yeah, and I, like I mentioned, so it's not something. I mean, the optimizer is smart enough, and it does, do the right thing almost most of the times. This is specifically for cases where you'll see that something's not working the way you expect it to be. This is just one of the things that you can use to make sure it's doing the right thing. And obviously, this again, like, is one of the things that is a rare. Just wanted to make that clear that it's not a mandatory requirement that you need to add hint to your queries, but it's more of an extra thing that you have in the event you need it.
Yeah, no, it's definitely not mandatory, but I do think there is a bit of a philosophical, and I'm sure like people would disagree philosophically on what the best recommendation is. Certainly, I have told some customers in the past just use hint for everything because you're just being careful. Like,
yeah, it doesn't hurt. It doesn't hurt.
It doesn't hurt. There's no downside to doing it, and you're not leaving anything to statistics or chance or anything like that. Created that index for that query, so just tell us to use it. And there was another question here. Let me go back a little bit because I want to address it. It was related to my comment that you wouldn't want to create an index on a attribute, on a Boolean attribute, because maybe you'd only filter out half your documents, and that's true. If you have an attribute which is Boolean, but the vast majority of your items have one value and only a tiny minority of your items have the other value, like whether there's an anomaly, you might have a Boolean that says whether an anomaly exists and it's true or false, and maybe most of them are false and only a few things have an anomaly. So you'd want to use an index to find the things that have an anomaly. However, in NoSQL databases, we have this extra flexibility that doesn't exist in relational databases. We can have attributes that exist in some documents but not others. And that makes it possible to create an index on attributes which don't exist in every row in the table or document in the collection. And if you do that in DocumentDB, you're creating what's called a sparse index. So instead of having a Boolean which represents whether an anomaly exists, you can just have an attribute called anomaly exists and create an index on that attribute. And that only exists in documents which have an anomaly. So the index would be quite small. Documents in the index would be ones which have an anomaly. So using these sparse indexes is a really great tool for these types of needle in the haystack problems. I see people use it for anomalies. I see people use it for error states. If there's some sort of sensor which is in an error state and you want to scan for those, it's very easy to have like an error state sparse index. Gaming use cases will have like the winner of the game, or the champion or something like that. Only that player would have that champion field in their document, and so those sparse indexes are very useful. And if you want to read, I posted a link in the chat to a document page about sparse indexes.
Cool. Thanks, Chad. I think just moving on, trying to make sure we go through all the learnings. Again, one of the things Chad earlier talked about is indexes should have high selectivity. And this actually goes really well. We're talking about creating indexes on Boolean fields. So we actually had a customer who wanted to, learn why, despite having the indexes on queries that, the fields that they were using in their queries, the execution times were similar to those without indexes. This is interesting because they created the indexes, they see in the query plan that it is using the indexes, but the execution times are, pretty much the same. And in this case, this, again, data is anonymized, but an example data set for this example would be just airline data. So this is just few records that I'm going to show in the demo later, but they essentially have fields which include date, delay on how often the flight's delayed, how much distance does it cover, what's the origin destination, what's the origin and the destination, how many stops does it have, and what's the status, whether the flight's active or inactive. In this case, what the customer had done is they had actually created indexes on the fields status and stops. Now, it's interesting because the value of status could be active and inactive, and the value of stops could be 0, 1, or 2. But if you look at most of the sample queries that the customer had, most of them involved a filter on origin and destination. So yes, the queries did include the fields status and stops, but they also included a filter on typically the origin and the destination. So in this case, even though the customer had an index on status and stops, they were not selective, and they really didn't help when it comes to locating the records, because like I mentioned, status could be active or inactive, and stops could be 0, 1, or 2. So for example, the query that we saw earlier, if you're trying to search for all flights where the origin was LAX, the status active, and it's a nonstop, the optimizer is still performing a collection scan to find all records where the origin is LAX. Sure, the indexes do help filter out on the other two fields, but it doesn't on the first one. And that's where bulk of the slowness was observed in the query. So to resolve this issue, a better approach in this case would be to create a compound index that includes a field like origin or destination, which has better cardinality. Specifically in this case, a better approach would be to have indexes on all three fields together that are often seen in the query. For instance, origin, status, and stops, which show up in most of their queries, and then another index on destination, status, and stops, which again show up together in a lot of their queries. So essentially, if you have high indexes that have high selectivity, what the help here you get is the optimizer is able to filter out a lot of records, making sure you're using the indexes for your queries and doing less work, less scans, and therefore less IOs. I actually have a demo for this, but before I jump into that, I want to see if there's any questions in the chat.
Chad,
how we chat? But I did want. Yeah, we're okay on time. Yeah, I think we're okay on time. We'll take 5 more minutes with Eaton, and then we'll jump into the final bit.
Should be quick.
I did want to. Can you go back to the slide really quick? I did want to just in the word cardinality really quick, because that's something base guys throw around a lot. Not everybody took linear algebra or those types of classes. So cardinality really means the number of distinct values that a field has. So if you have a Boolean attribute, then its cardinality is 2, because you can have true or false distinct values. Obviously a field like origin or destination is going to have, however many airports there are in the world, thousands of values potentially. And so that has much higher cardinality, and means your index is more selective. Of course, the highest cardinality you can get is a unique attribute. So DocumentDB, every attribute has the underscore ID field. It's guaranteed to be unique. And so that index on underscore ID has the cardinality of the number of documents in your collection, and so it is the most selective index you can pick from. So I just wanted to explain that really quick.
Yeah, thanks. That's a good call out. I'll try to speed things up a little bit. So let's dive right into some queries to show you guys some of the befores and afters. So the first query I'm going to run is essentially try to find all flights where the origin is LAX, the status is active, and it has 0 stops. So when I run this query today, as you can see, it's doing a collection scan, and it's taking 188 milliseconds to answer the query. To answer this query better, so even though I have indexes, it ends up doing a full call scan. What I'm going to now do is create a compound index on the essentially the origin, status, and stops fields. By doing that, if I rerun the query and try to see the explain plan, you'll see that the query now takes 5 milliseconds, which is a big improvement over the previous one, and we are using the index. This makes sense because that's essentially what we had in our query, and we wanted to make sure that the optimizer is filtering those records out and using the index. So this essentially is just showing you that even though if you may have indexes on certain fields, they may not be helpful. So creating the right indexes on the right fields, very, very important. So I'll speed up, just go to the last learning. So this, again, goes back to one of the things Chad mentioned earlier, is that the order of operations in your query is very important. So we had a customer who reached out to us, again, typical use case where they wanted to know, hey, for this kind of data set and a specific query shape, the query is not performing as well as they would have expected. In this case, the customer has a field called event, which has an array of multiple documents. So the event has two documents each, array with 2 documents each inside the array. What the customer's query was, they're essentially doing an unwind. So what unwind does first is it takes the array element and creates a unique document for each element inside the array. So if our array event here had 2 JSON documents, unwind would essentially unwind those and give you 2 unique documents. And followed by the unwind, the query had a match, which was trying to find all of those unwound documents where event ID is 1. Now, the customer has an index on event.eventID. But the problem here is because the unwind stage is the first stage, it precedes the match stage. And thus, the query optimizer actually does a full scan when performing the unwind. So you're not really utilizing the index. And a bulk of the time is spent here before the match stage. So to improve this query, what we did is we worked with the customer to essentially rewrite this query. And we rewrote this query by adding an extra filter condition before the unwind stage. So by doing this, what we get to do is essentially use the index to filter out all the documents that would not be able to answer this query later on, and thereby leverage the index, then do the unwind, and then do another match. And note the second match is still required because you need to remove all the unwound elements that are not required. So by doing this and by adding an extra match before an unwind, we got to utilize the index, thereby improving the overall performance of this query. I do have a demo for this, but I want to be mindful of time. So Chad, how are we doing on time?
Yeah, I think we should. I think we should skip the demo on this one just to save time. We only have 10 minutes left. So,
makes sense.
Yeah, thanks for that.
Yeah, makes sense. So just to summarize, creating indexes, very important. You have the ability to use hints when you feel like the optimizer is not doing the right thing. When you do create indexes, make sure they're created on fields which have high cardinality. And last but not the least, order of different operators in your query do matter. They're very important. So it's important to make sure that you're leveraging the indexes by having the appropriate orders in your query. And with that,
Joe, I had a question for you on this. Would you say that the order of things in the index matters too? Like, do we need to to say we're going to create the index on the highest cardinality attribute first, and then go, sort of progressively down in cardinality, or does it not matter?
Is the question kind of leading? Should we index everything, or only selected fields?
If my index is on destination and number of stops or something like that. If I create my index on destination and then number of stops, is that the same as if I created my index on number of stops and then destination, or does the order of attributes in the index matter?
I don't think so. I don't think it makes a difference.
Okay.
Okay. All right.
Okay, good. All right. Thanks, Meet. Nice to have our first guests on the show. So I want to thank you for coming and joining us. I'm sure you'll be a recurring guest. Being that you work on the product team, we're going to have you on a lot. Thanks
hopefully he comes back. Chad, hopefully he comes back.
Yeah. Absolutely. We didn't scare him away. All right. Thanks, Meet. All right. I'm going to bring in our next guest here. 1 second.
And as you can see, Chad, I'm having an excellent hair day today.
Yeah. I'm disappointed that you don't have a Cobra headband or something like that.
Going to the store right after this.
They're going to be very disappointed.
I know they like when we wear the merch. They do.
Absolutely. I want to bring in our next guest, Brian Hess. He's a senior NoSQL specialist solution architect. So he's in the same role as me. We work on the same team. Thanks, Brian, for joining us today. Just Morning. A little intro. We have this distinction in DocumentDB that doesn't exist in a lot of the other AWS databases, which is that we don't use the AWS SDK to talk to our database. We use the open source drivers that customers are already using to talk to MongoDB, for example. And that means that if you go to create a Lambda function that talks to DocumentDB, you can't just use the Lambda source code editor, because while it does include the AWS SDKs, it doesn't include any of the MongoDB drivers. And so that does make it a little hard to just work with editing code right in the Lambda console. And Brian is joining us today because he's created a unique solution to the problem. And so I want him to that, but it involves creating a Lambda layer. And so let me turn it over to Brian. Thanks for joining us.
Yeah. Thanks for having me. You guys can hear me all right?
Yep, we can hear you.
Excellent. So I'm going to, I guess I'll do some intro and then I'll start sharing my screen. But the idea, as Chad was saying, that some of the databases that are in AWS are kind of more, let me put it the other way. The Lambda environment that you get has certain of an environment and libraries already loaded into it, including the AWS SDK. And so something like DynamoDB, that's the requirements that you need to be able to open and talk to it. But for DocumentDB and some of the other databases as well, they need a driver. And so that's not automatically part of the environment. Like, let's say you're writing a Python Lambda function, that's the one I'm going to demonstrate. You don't have the PyMongo as part of the of that environment. So what you're left with when you develop your Lambda is really to develop it, sort of on another development environment on your Linux box or what have you, and then you build your source code. You combined it with all the drivers into a giant zip file, and you kind of upload the zip into Lambda, and then you can run it from there. And if you need to iterate, you need to tweak it, you come back to your environment, make a change, upload it, etc. And I just found that to be kind of clumsy when I was really getting started with DocumentDB, and found that I kept doing the same things over and over again, and then I'm writing this simple little Lambda, but I have to do all this other machinery. And I stumbled into this thing of Lambda functions. Sorry, Lambda layers. I'm not sure that it's very well advertised, but I found it to be really handy for at least for DocumentDB. So I'm going to start sharing my screen now. Let's see if it lets me choose. All right. So you should be able to see the screen. No? Did it work? It did. Okay. So what I have, let's start back up for a moment. What I have is a DocumentDB cluster. It's just 3 nodes. It's nothing too exciting here. I have used Secrets Manager to store the username and password for that environment, so we don't have to muck around with passwords or anything going on. I created a Cloud9 environment, much like Meet did, which let me sort of just insert a couple of silly pieces of data here. So I have this demo database, and in it created a test collection that has just a couple of elements in it. I'm not really all that focused on the DocumentDB, like the data itself and the query API. So this is very toy of an environment. So similarly, I'm not going to build a crazy Lambda. Keep it pretty simple here as well. So what I have is a Lambda that I wrote that just does some really basic stuff. So it makes a connection. It grabs the credentials from Secrets Manager. It makes a connection using PyMongo, and then the event handler, when it comes in, will have something that is a filter, and I'll just use that filter to find the data. And I just filtered out the object ID because, well, because a lot of times it's not that interesting. So this is, this would work if we were in an environment where we could just go ahead and import PyMongo and BSON, because that's all we need. So if we kind of bust out here, and I have a test set up that basically, let's look at test 2, where we say, I'm looking for the records that have A equal to 1. So we test this, and what we're going to get is an error because it says, I have no idea what PyMongo is. So separate from that, I'll come back out here. Let's just open it in another tab. And there's layers. So in the layers here, we created a DocumentDB Python layer, which has Motor and PyMongo included in it. There's a link here that Chad put together. There's sort of a way to build this. It uses some Docker stuff, so it has the dependencies that are needed in it, et cetera. But in there, you can also sort of get down into just the command, which basically is going to install the packages for a couple different types of versions of Python, zip it up, and then create a Lambda layer. So I ran that, and you end up with this.
Just to note,
layer.
it doesn't just include the Python packages. It also includes the PIM file, so you can connect with SSL, which is important for
very good point.
DocumentDB.
Very good point. That's something else that's sort of another piece of the puzzle is you need to have this PEM file for the security for connecting using TLS. And so we need to get that into the environment as well. It turns out that, so we create this Lambda layer. If we come back to our Lambda now, I'm going to clear that error. There's this layers tab here. When you click it, you get a different sort of set of stuff down here. So we'll add a layer. It'll be this custom layer that I already created. Pick version 1, and we add it. It's going to take a moment to kind of come into the environment. So now it's there and available to be run. One quick thing to note, thank you for reminding me, Chad, is that it includes the PEM file. When the layer gets added to the environment, it goes under /opt. So our zip file started at Python, and it included the PEM file there. So you know where this stuff is going to live. So if you needed auxiliary files in there, you could put them in as well. So if we run this silly test, test 2, which was looking for A equals 1, now we're going to go ahead and run, and we see that we successfully go and we find that record. And well, more importantly, we found PyMongo, right? That's all we're trying to show here. So now if I go and I want to create another function, it's really easy to sort of create a function. I'll author it from scratch. It's sort of the demo 2 function. I'll make it a Python 3.6. I have a role that I was already using. And then we create the function. And now I can just start add the layer just like we were doing before. Give it a moment. And then we sort of come on down here and we can just do import PyMongo and we're off to the races. So you can do,
All right, thanks.
yeah, you could do
Brian.
more with this if you had some other code that you wanted more regularly in your stuff, but we kept this one pretty thin to just this. And you can add multiple layers as well, which is pretty handy.
Super cool. I didn't even know you could do
Yeah.
that. That's
Yeah, I liked that.
Yeah, so there's
I'm gonna go steal
some-
that. That's good.
There's some examples out there for Python and Node.js. If you look in our samples repo, I posted the link in the chat. One thing I did find is that when I just wrote a sample npm thing, and the default 3-second timeout for the Lambda function wasn't long enough. I don't know if Node.js took longer, like search the include path or something like that. I don't know what was going on there, but when I increased my timeout to 10 seconds, it worked fine and connected right into DocumentDB. All right, we're out of time for today. I want to thank everybody for coming, including our guests Brian and Meet. Thanks for being here today. And let's just wrap it up here. Oops. We have our next episode 2 weeks from today, November 5th. Same bad time, same bad channel, twitch.tv/AWS, 8 a.m. Pacific time, really early for Joe. Hopefully he'll have some good Cobra Kai merch by then. Thanks for coming today. Thanks for joining us. And we'll see you in 2 weeks.
Thanks,
Okay?
folks. Thanks, Chad.
Have a nice weekend. Bye-bye.
All right.